Hello and welcome, I'm your Code Monkey. In this lecture, we're going to learn about preprocessor directives. This is how we can give some instructions to the compiler itself, which are run during compilation time and not during runtime. Okay, so preprocessor directives. With this, we can tell the compiler some things. The simplest thing we can do is just define some symbol. For that, we need to do it at the very top of the file. So over here, we start with a number sign or a hash sign. Then we write define, and now we can define whatever name we want to give to this symbol. So something like testing. And usually as a convention, you write the symbol names in all uppercase. So that's it. This defines a symbol. That's all it takes. It doesn't equal to anything. It's just a symbol. Symbols either exist or don't exist. So they're not variables that hold any data. They are just defined or undefined. So here we define the testing symbol. And then anywhere else in our code base, we can do an if. So for example, let's go over here. Let's do again the number sign, then write if. And then whatever symbol we want, like let's say testing. And then to terminate our if, we do an if. And yep, just like this. So now, for example, we can put some line of code inside of this one. Yep, just like this. And now what this is doing is basically telling the compiler to either include or not include this line, depending on if the testing symbol, if that one is defined. Like this, if we run our code, if there it is, it did say testing. But now if we remove this define up here, right away Visual Studio even helps us by graying this out. It means this code is not going to be included in the compilation. So right now, if we run this, and if there it is, now we do not see that message. Essentially, this code right here, this does not exist at all in the final program. This if over here is adding some instructions to the compilation itself, and since the symbol is not defined, this code will not be included in the final program. It literally does not exist. One very common use case for this is for debugging. So you can add some complex code for supporting debugging, doing all kinds of log messages and so on, but you might not want that code to be using up performance in the final build. So you define a symbol in order to make some kind of debug build, and then you remove that define when you make the final build so that the debug code does not run. That's one of the main ways that preprocessor directives are used. And just like in pretty much any kind of programming, if we have an if, we also have an else. So you can write else and then do whatever we want. So for example, over here, let's say not testing. And yep, right away in the colors we can see, so this one is not going to run because testing is not defined, whereas this one is going to run. And if we go up here and if we define our testing symbol, and yep, now this one does run and this one does not run. So you can make an if and an else, just make sure it always ends with an end if. Or alternatively, we also have elif. This is basically else if. So elif if something, let's define a testing2, and then let's do an else. So up here, let's put testing2. And yep, so if we define testing, then it runs this one, okay? If we don't define testing, then it goes into this else if and checks, does this one exist? It does not exist, so it runs this one. Whereas if we define our testing2, if so, then yep, it runs this one. So all of this, some simple if-else logic, just like you're used to. And right now you might be thinking, okay, so what exactly is the difference between this and just writing a normal if? So just a bool testing, let's set it to true, if testing, if so, then do something, if not, don't do it. So the difference between this and this, the difference is that the normal if, this one will be included in the final program. This if will only be evaluated at runtime, so only when the code is actually running. Whereas this one, for preprocessor ifs, these are evaluated during compilation times. And whatever does not match the if, like this one is simply not included in the final build at all. So this code literally does not exist at runtime. The compiler evaluates the ifs in order to figure out if something should be included or not. And after the code is compiled, all of this does nothing. All of this is replaced by just the things that are included. So this one is a runtime if, and this one is a compile time if. Another important thing about the define is how it only applies to this one file. So here we have this file, and I created this brand new one. So it's a completely separate file. And over here, let's define the testing and just do our normal testing, just like this. So yep, it does run on this one. But now on this one, if we try doing the same thing, nope, here this code will not run, will not be included. That is because this testing symbol is not defined anywhere in this file. It is only defined on this one. So the defines are on a per file basis. But we also have options for project-wide defines. There are two main ones that are automatically defined by default. One of them is called debug, and the other one is called release. These are the two automatic configurations. So up top here we have a drop-down menu. This one is for the configurations. And by default, it always starts with a debug and a release one. And doing so, these automatically create defines and applies it to the entire project. So here with this set to debug, if we have the if debug, this one is going to run. And same thing on this other file. If we define this as debug, yep, this one also runs. So this debug define applies to the entire project. Like I said, one common use case for this is for debugging. So rather than defining a debug symbol on every single one of your files, instead of that, just use the built-in configuration manager to use this debug, and then when making the final build, you swap it over to release, and doing so, all of this debug code will no longer be included. So setting it to release both does that and also creates a new release. So yep, this is a super easy way to enable project-wide defines. And if we go on the configuration manager here we can click on this and we can add some new ones. We can add, for example, testing. And now we don't need to define a testing anywhere, and we can do if testing, and yep, it does work. Then over here, if we just write if and we press space, we see a bunch of auto-completion. So we can see a bunch of defines that are created by default. For example, these over here are related to the .NET version, the .NET Core version, and so on. So with this, you can write some version-dependent code. For example, some code that depends on a specific version, like only works on .NET 6 or greater. So you can do this, run that code, and then have an else. And if the project is not set up with .NET 6 or greater, you can then fire an error, log a message, or do something like that. Now, another place where we can create project-wide defines is in the project properties. So over here on the right side, let's open up the Solution Explorer. Let's right-click on the project. Important is over here on the project, not on the solution. So right-click over here, go inside Properties. And then over here, let's scroll down under Build. Yep, just like this. And up here, we have a bunch of custom symbols that we can add. These are related to the configuration builds that we saw. So we've got debug, release, and our testing one. And again, these are project-wide, so these will work on all the files. So over here, like C# course, just add it. And yep, there you go, it's enabled. And over here on any of these, I can search for C# course, and yep, it does work. And again, project-wide, so it works on both that one as well as on this one. Okay, great. Now, other defines are the ones inside of Unity. So here's a script inside that Unity project. And over here, we can write if. And again, we do see a whole ton of defaults. There's a bunch for all kinds of interesting things. And the main ones are really just over here for the versions. So you want to write some code that requires 2018.1 or newer. Any of these. You can make it based on build, so it has to be on a standalone Windows build and so on. Or actually one that is really important when making tools is this one for the Unity editor. With this, you can either include or not include some code that is specifically related to the Unity editor. Then in Unity, we can also add project-wide defines. So let's go into Edit and down here onto Project Settings. Then over here, let's go on the Player tab and let's scroll down under Other Settings. Let's keep scrolling down. And if here it is, we've got the script compilation, so the scripting defined symbols. And if it's over here that you can add whatever symbols you want. You can write anything, and again, these will be global defines that apply to every script in your entire Unity project. Okay, so that's defines in if, but there are more preprocessor directives. One that I use every once in a while is one that is called region. You write this, and then optionally you give it some kind of name like functions, and then at the end you write and region. Any of this creates a region, and importantly, over here in Visual Studio, this one creates a collapsible menu. So we can collapse or expand. This can become quite useful in large files for organization. So for example, you could make a region for all of your fields and make end region, then make another region for all of your statics. You could have it like this, and even on a giant file, things will look quite manageable. Another simple one is both warning and error. So we just write error, some error. And if that's it, very simply, this creates an error. So it says some error. And if you look down here on the error list, yep, we have an error. So this is basically a compilation error. We cannot compile like this. And as for when would you use it? Well, you can actually combine this with the if. So for example, let's go with if. So for example, if we are not using .NET 8, if so, then spawn some error. If not, then don't spawn that error. So these can be quite useful for validation on your project. And related to that, we have another one, and that other one is the warning. And this one, really the same thing. So this is a warning. This one is not an error, so it does not stop compilation. It's just a warning. So down here on the error list, if we include warnings, yep, we see this is a warning. And related to that is another very useful one for disabling some warnings. For example, let's say we have some code here and we define some kind of variable, but we never initialize it, we never use it. And let's say this was actually intentional. Right now, if you do this, we see the little squiggle line. So this is a warning. It is saying the variable is declared, but never used. And down here on the error list, yep, we do see that same thing. If we wanted to disable this warning, if so, then we can just write pragma warning and then disable, and then the actual number for the warning. So over here, let's mouse over and see. Okay, so this is warning 0168. So up here, disable 0168. And if there you go, it does disable that warning. So that one no longer shows up as a warning anywhere. So if you have some warnings that you know are not a problem, you can use this to suppress them. Or alternatively, you can just do just this, pragma warning disable, and this is going to disable every single warning. Also, this does not have to be written just on top of the file. You can write this anywhere. So for example, right before this line, we can write this one. And then let's say we want to ignore literally just this warning and nothing else. And then afterwards, we can write pragma warning restore. And now if we write a similar error, yep, there it is. Now this one does show up the warning. So it only suppresses the warnings directly within both of these lines. All right, so that's preprocessor directives in C#. It's how you can give instructions to the compiler itself, which mainly allows you to write conditional logic that will run at compile time instead of at runtime.